So again, we're going to be working today looking at some graphing with logarithmic equations. So we're going to go ahead. We're going to get our log of x typed in. We're going to take a peek at what this looks like. So I hit this at first, and it looks like, just by first view, okay, so it's coming along here, and it kind of stops right here, sort of like a square root equation would. But here's the thing. It doesn't stop. This is going to keep coming along here, and it's going to keep going right down along the y-axis, okay, even though I don't see it. So when I'm going to graph this, when I look at my chart, okay, we'll talk about the error in a minute, because that should be ringing a bell a little bit here. We're going to plot the whole number points that we see. So we're going to plot a point at 1, 0, and then our goal is always to hopefully find one more whole number point. In this case, we do at 10, 1. You typically aren't going to find more than 2. Occasionally, if there's a shift, you might find a third. But it's probably going to be just those 2. So when I kind of eyeball the graph here, I'm like, okay, so this is going to come along here. And it's going to hug the y-axis, but it's not going to cross it. But it is going to keep going. It does not stop. Okay, that's a big thing to keep track of here. So when I do start to look at some of the values that are here, where we hopefully can make some connections, okay, the first thing we're going to notice is the vertical asymptote. Now, we've talked about that word before. The asymptote's kind of our border, our do not cross line. So that usually is the value that this comes up close to. The chart can actually help me find this. When I'm doing this, the asymptote's going to be where that first error message starts. Because notice error, 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 error. Wherever that first message is, that's where my vertical asymptote is. So x equals 0 in this case. And if I drew that in on my graph, and I like to do this just so I don't do something silly. Like when I go to make my graph, I get sloppy and I'm like, woo, it's way over here, because that's not good. Okay, that's not going to be an accurate idea of what's going on. So it's going to be at x equals 0 for my vertical asymptote unless, bless you, I have a right or left shift. And we'll talk about the shifts here in just a minute. But if it's up and down, doesn't move. But if it's left or right, it's going to move along with it. We're also going to be looking for the x-intercept. Now, x-intercepts, again, occur when y equals 0. So sometimes I may get fortunate, and I can just go to my calculator, and I'll see a place where, oh, y equals 0. Oh, it's 1, 0. Okay. That's going to be pretty normal, again, unless I have shifts. So, something to keep in mind. So, speaking of the shifts, and again, transformation is a fancy word for saying shift. If whatever plus or minus I have is inside the parentheses, sort of like number 28 is, or that minus 2 is on number 30. Okay, that's going to be my left-right shift. And just like always, it's the opposite of what I think. Okay, so if it's plus inside, I'm going left. If it's minus inside, I'm going right. You're like, dang, that's a lot like all these other ones we've been doing. It is. And then if I have a value that's outside the parentheses, sort of like we see at number 29, that's going to be my up and down shifts. And just like always, those are the ones that do what we think they would. Up is plus and down is minus. So you're like, yeah, it is kind of like the growth and decay and the square root equations that we've drawn. The shifts are the same thing. So once we've got that under control, then we can start to look at some of these other values and hopefully make some connections. So my domain, I do see that it goes right forever, but it doesn't go left forever. It's coming along here, and then it kind of slows down near 0. Okay, we're going to make a connection here. My domain in this case is from 0 to infinity, but here's the bigger connection. Wherever my asymptote is, in this case it was at 0, wherever my asymptote is, that's going to be where my domain starts. So if I'd have moved left 2, my asymptote would start at -2. If I had right 3, and my asymptote was over here at 3, that's where my domain starts. So it's kind of a general rule that I can use to make sure that I get that value right. And then this time, range is going to be the easy part. So my domain and range actually are an exact flip of growth and decay, an inverse. When I was doing growth and decay, my domain was -infinity to infinity, and this moved with my up or down shift. But now it's just the left and right shift that we're looking at. And looking at the picture can help me with that. So as we do any of these, and again, practice makes perfect. I will be when we're doing worksheets. And in case you didn't hear, we were asking why it's not asking for the actual transformation. I think that's a tremendous idea. And like I said, on the worksheets, we'll do it. So let's take care of that first. On 28, what is my transformation? Left 1. So, since I moved left 1, where's that going to have my asymptote be at? At -1. Vertical asymptote. Yep. So I guess I could have written that down here instead of writing it up top, but that's okay. So my vertical asymptote is that x equals -1. And yes, I need the x equals, because that tells me, someone who is mathematically knowledgeable, that it's an up and down asymptote that we're looking at. Well, let's take a peek here. Let's draw this in. So I'm going to have an asymptote at x is -1. Because normally it's at 0, but we moved it left 1. So again, let's make some connections. My domain and my vertical asymptote are directly connected. Exactly. My domain's going to be -1 to infinity. My range never changes, so I don't have to even think about that. Now, the x-intercept, we will play with that here momentarily. Let's see if we get fortunate and can get it from the calculator. And if we can't, we do have another way we can do it. So, all right, so log of x plus 1. Make sure it all stays together. Don't close the parenthesis too soon on this one. So I'm going to look at the graph for a second before we look at the chart, just so I see how this is working. Notice my graph moved over to the left. And if you could see it continue, it would come down this way. So we're feeling pretty good that we did this right. When I look at my chart, where's the first error message? It's at -1, where my asymptote's at. So I look for my points to graph, and I see I got a point at 0, 0, and 9, 1. What a coincidence. They just moved left 1 from where our first ones were. And so when I go to make the picture reminders, I'm going to go through those 2 dots, but again, right, we don't cross the dotted line. We don't cross the asymptote. But I do need to keep it going. It doesn't stop. And I did get fortunate this time in that my x-intercept is going to be easy to calculate because I see where that 0 is at. So my x-intercept is at 0, 0. Because remember, wherever y equals 0, that's where my x-intercept is at.
That's what I was confused about. You did have like -1, so I was like, what? I don't think that was.
Yeah, that's where we've got to keep straight. When you have x equals a value, that's telling me that it's a line, okay? Where an intercept is a coordinate point. And that's one of those things you just got to work on a little bit to kind of clean up and make sure we're getting the hang of. But again, we're going to get plenty of opportunities to clean that up. But do keep asking questions if there's parts you're like, wait a minute, what are you doing? So we can get that set. All right, so let's roll this on 29 and see what we got. The transformation is up 4. So is a transformation of up 4 going to move my asymptote? No. So where's my asymptote going to be? Still going to be at 0 because I didn't move it left or right. Okay, no left or right movement. That asymptote stays at 0. So you're like, okay, so before I ever graph it, because we don't want to be calculator dependent, what's my domain going to be? Make the connection, whatever your vertical asymptote is, that's where your domain starts. Okay? Directly connected. These two values are going to be the same. My range, no matter what shifts I make, are always going to be the same. So as we're doing this, and we're trying to get the graph part, okay, we got to be careful this time. Because notice this time the plus 4 isn't in the parentheses. It isn't in the logarithm. It's on the outside, which is going to get my shift. So let's look at the picture, make sure we're going good here. Okay, notice it moved up, and that's what it should have done. That's why it's good to write my transformation down first. Look at my table. There's the 0, there's the error, so I know my asymptote's in the right spot. So 1, 4, because normally it's at 1, 0, so we moved it up. And 10, 5. And again, take my 2 dots, connect them, and hug right along that asymptote. Now this time life is not as nice to us. Because I'm looking around and I'm like, I don't see y equals 0 anywhere because it starts at 4 and gets bigger. So how do I figure this out? Okay, we're going to use one of our tricks that we learned yesterday to figure this out because it's going to be the easiest way of doing it. I will give you some options, okay? I will give you an option on the calculator and an option to do it algebraically, then you can figure out which way you want to do it. But I'm going to do the algebra part first. So let me move this up a little bit. Okay, so I'm looking at this, and remember, my x-intercept is when y equals 0. So if I'm going to do this algebra-wise, okay, I'm going to take my equation here. I'm going to plug the 0 in for y. So 0 equals log. What's that little base number with log again if I don't see one? 10. So log 10 of x plus 4. My job is going to be to figure out what x is. So, first job. Before we do that, we have to make sure we isolate our log term before we exponentiate. So we're going to minus the 4 first. Okay, that's going to be my first job. So if I minus 4 to both sides, and now, if you look up at the kind of at the top of your page when we were doing the inverses, how we got rid of the log is we exponentiated. Sounds like such a huge word, but it's really not a bad concept. So we use a 10 to exponentiate. And I need to know what 10 to the negative 4th power is. So now let's see if your calculators do the same thing mine did when I first did this. We may have to chat about this. Yeah, that's what I was hoping wasn't going to happen to some of you. Okay, we don't want to write 1e negative 4, okay? What that means is we're going to take 1 times 10 to the negative 4th. It's like doing it with scientific notation. So here's what that means to us. I'm going to put a 1 here. Okay, normally my decimal point would be right here. And I want to move 4 places to the left. Well, to do that, got to add some zeros. So 1, 2, 3, 4. So my x-intercept is at 0.0001. 0. That's a really tiny number. That's really, really close to 0. But that's what we've got to do sometimes if the chart can't help me. Otherwise, what you'd have to do is you'd have to trap it in like we were doing before. But to me, that's actually going to be more work. I'll show you on this one, but this isn't the route I would go. So if you were going to go that way, you would hit, let's see, how do I want to do this? Second calc. I'd want to find the 0, so I'd want this part. And you remember before when we were trapping? Well, the problem gets to be when I try to trap it in, okay, I've got to make sure when I'm to the left, I'm not going to see any values. To the right, I am, and you see there's the 1e to the negative 4 again. So I have options, but again, the algebra way I think is going to be more sensible and less frustrating, and that's what I want. I want less frustrating for you. But if that's the only thing you're getting stuck on so far, that's pretty good because, well, the other stuff is where most of the points would be anyway. Okay, one more on here, and then we'll do some worksheet stuff together here. Okay, oh, double transformation this time. Where are we moving on number 30? Nice, right 2. And down 3. Okay, let's make connections. Where's my vertical asymptote going to be? Okay, at 2. Because again, my asymptote's going to move with left and right shifts. Up and down shifts don't do anything to my asymptote. Exactly. My domain directly connects with my vertical asymptote is 2 to infinity. My range still isn't going to change. So once I have that set, now I'm ready to go to the calculator. And again, make sure you're typing it in exactly the way that it is on there. So close after the -2. Make sure that -3 is after, so we're shifting down. We'll take a peek at the graph, make sure this makes sense. I've moved right, I've moved down. That's good. I look at my chart. First error message is at 2. That's good. So 3, -3. And we're a little off the chart with the second one, but that's okay. 12, -2. Hug that asymptote. And I will just give you a heads up when we get to the quiz on this, okay? I will be looking for the 2 points that you get to make your line. If you just make a quick scribble and I can't tell that you accurately found those, I will get you for it. So typically, let's say if number 30 was a problem on the quiz, you would get points for the transformations, the graph, the domain, the range, so half, whole. That's probably a 4-point question. If you weren't careful with your points, you'd lose 1 out of 4. Not bad. But still, we don't want to lose cheapy points that way. So I start to look, and I'm like, okay, am I going to get fortunate this time with my... Now, let's be real. I could keep scrolling down for a while and hope that I make it to 0 for my y, but I really am, I'm up to 36 already, and I'm still not really close. I really don't like this idea. So what I'm going to do instead, I'm going back to algebra again. So you're like, oh boy. So, again, 0 in for y. Remember, when I'm looking for my x-intercept, my y value is always 0. So it's 0 equals, okay, log 10 x minus 2 minus 3. Now this could get to be a little bit cramped here in a minute, but we'll make it work. Okay, first job. Isolate the log term. Add 3. So 3 I know. I'm with you on this. We're gonna have to get creative here in a minute. Okay. Now what?
Now you the other 10 thing.
The other 10 thing. We're gonna exponentiate. Okay, and we're gonna move this arrow up to here so we can kind of start seeing what's going on here a little bit better. So 10 to the third power is 1,000 equals x minus 2, because that's still there. It was in the parentheses. So then what's my last job? To get x by itself. So what's my last step? Add 2. You're like, really? Yeah, you'd have had to scroll all the way down to 1,002 before you got to the y value that you wanted. So my x-intercept is 0, 1,002. Good luck graphing that. I don't feel like having a graph that big. Okay, so here's what we're going to do with this. We're going to take what we just learned here. So let me get us over to the worksheet that we're looking at, because that's the actual assignment for today. So on the front, notice what you're being asked for. Okay? And we're going to make one adjustment here while we're here too. Okay? Name the transformations, name the shifts, identify the domain and range, sketch the graph. I'm not making you find the x-intercept on these, but I do need you to make an adjustment for me, because I just noticed this. Every place that you see the little numbers in next to log, yeah, we need to remove those. Remove them. Removed. Because what would happen if we were doing them in other bases is I'd have to be teaching you a different way of doing this, and for right now we need to keep life simple. Simple is good. So on the front, we're just going to keep doing what we've been doing for these last 3, kind of working those things out. The asymptote?
Yeah, that.
That's always a good idea to put on here, even if you're not being asked for it, just because it helps you with your domain and range. So it might not be a bad idea to, actually, let's go with that. Because if I identify the asymptote, that's going to help me make sure I don't mess my domain up. So it's good to just get the extra practice with those as we're doing that a bit more. And if you really want to press it and go for an x-intercept, you can, but I'm not going to press the issue on that. At least not yet. We may retouch on that again later. So you're like, okay, so that's the front, kind of playing with those, making sure I got this down. So then when I flip to the back, it goes back over what we did yesterday. So what I'd like to do is hit up one of each of these with you, just to make sure, kind of do it as a review. So evaluate each expression. So remember what we were talking about yesterday. Okay, that's my little number. That's always going to be my base. This is always going to be my answer, my solution. So it's my job to figure out what power I take 6 to get 216. And since you don't know the other little trick on the calculator quite yet, because I want you to be able to do some things with your exponents on your own, we may have to play a little bit. So, it's 3, I'm being told. Correct. Okay? So it's 3. And that's what I'm going to do on... That's it. Just what the magic power is to make it work. So it's... I knew you were going to say that. Oh, I'm such a sucker. Okay. Reminder from yesterday on a problem like 8, because this is going to show up again enough on other things that I don't mind quite so much. You're like, okay, 3 to some power equals 1/9. Now, 2 things to keep in mind here, okay? First job. 3 to what power gets me to 9? 2. And what do I know happens when I go from a whole number to a fraction answer? And what do I do to an exponent to make it flip? Make it negative. Okay.
So that's it.
That's it.
Wow.
So again, whenever you see a whole number to a fraction or the other way, okay, figure out what you take this to get to this. 3 squared gets you to 9. And then the negative is the part that makes it flip. And you can always check that in the calculator even. 3 to the negative 2, it'll say 0.111111. You go to math, enter, and you get that. Okay. Inverses. And I see something else that needs to get fixed. What the heck? I trust these worksheet makers to help me out, and then they let me down. I don't know. Yeah.
That'd be a great job.
Oh, yeah. So, inverse. Switch the x and y. And again, this is on your note sheet, the one we just got done with. We were working on that yesterday. Now, we need to figure out how to get y by itself. We do the exponentiate thing first this time. There you go. So, it's 3 this time, not 10. Good call, because my base is not 10. Oh, this might be like the best video ever. Okay. And then add 9. Now, again, be cautious. That 9's not going up in your exponent. Get that in there, get that set. And that's it. Once y is by itself, we're golden. And you start to see some of the things, you're like, you know what? Some of these rules kind of overlap with the different things, and they do. That's why, again, you get those little chunks of practice here and there. It makes life better. Okay, rewrite each equation in exponential form. Again, if I look back to what we were doing yesterday, again, notice you can even take your sheet, your note sheet, and kind of say, okay, so base, and that's my exponent, and that's my answer. And just look side by side at them. So you're like, okay, so base, 16. The exponent's the number on the other side of the equals. And that's my solution. And if you're not sure if that makes sense, you've always got a nice backup plan, which is I go to the calculator and I type in 16 to the second power. And if it equals 256, and it does, there we go. And I work it that way. Correct. If there's not a base number there, we assume it is 10. Even get that put in there. And then the nice thing sometimes when you're doing work is one section may help you figure out the other. Because I look at the last part, it says write each equation in logarithmic form. In other words, go from this form and go back to this form. So you start to look, you're like, okay, this might be a little more complicated. Okay, so log, my base number is the little number. So there's my base. Okay, so that's 5. And then the next number was the answer part. So there's my answer part. And then the exponent went over here. Base, exponent, solution. 5 squared is 25. Okay, that works. And I roll that out. So again, I've got the key over here, okay, ready to go for you. So if you need to check on anything, see how anything's going, do that. You know, if you run into a problem, let me know. I'm happy to help out. And for those of you wondering, our